Now, Peter told us at the beginning we have three big themes for our day. We're going to look at inequalities and equity issues. We're going to look at the CDs versus NCDs and the huge rise of NCDs later in the day. But first, we're going to look at the interface between climate change and health. Where do the arrows go? And to get us going and give us a keynote in this, we are really pleased to say that we have Johan Rockstro, who runs the Stockholm Resilience Center, not very far away from here, but who also, ladies and gentlemen, you may not be aware of this, runs a massive global project called Future Earth, which is multidisciplinary. It's getting people across different kinds of sciences to work together to try and see how we make sure that this precious place we call the planet Earth survives intact and healthy for the future, planet and people. A number of people have been working around this area. Yesterday, Global Health Action published a number of papers, which we are sponsoring as part of this conference, and 3 of the authors of the papers on climate change are going to get us going around this discussion with their views. So let's just have a look at a little video.
Our research on climate and health in pre-industrial Sweden showed that high levels of rainfall in the springtime reduced mortality rates, probably because of the enhanced growth of crops leading to a better food supply. A lot of rainfall in the autumn, on the other hand, increased the death toll. A chilly, humid climate might have facilitated the spread of communicable diseases and the rotten of harvest. Temperature, we found, played a less significant role for human health than precipitation.
As one of my greatest heroines, Gro Harlem Brundtland, first said, everything is connected to everything. Climate change is not only the biggest threat to human health in this century, but several climate mitigation measures have significant and almost immediate health co-benefits. But to capitalize on these synergies and tackle the public health impact in general, we need a much closer collaboration between academia, enterprises and international agencies.
One of the problems with climate change is that in hot countries, the days will be hotter and workplaces will be hotter. And it's a well-known fact that when it gets too hot, you cannot work, it reduces your income, and it affects the local economy. And this is one of the problems of climate change that has, until now, not been enough studied and analyzed and discussed. And this is the focus, the research I'm involved in.
Thank you so much. Wonderful to be here. Just like Hans, I love money, in particular natural capital. I'm a global sustainability science, an environmental nerd, as you may call me. And it's particularly important for me to be here today. And the summary is basically, I think this is potentially the most significant link to be made urgently now between health, sustainability, and human development. And the reason is very simple. We have, and I think this may be the most important scientific message to humanity, entered the Anthropocene. This is a new era of surprise and turbulence where we've moved from a connected to an hyper-connected, and from a hyper-connected to an interdependent world where the fundamental basis for human well-being, the biosphere, is sending back surprise injections into the economy and into health and into development. The Anthropocene is the dramatic notion that we, anthros, have become a geological force of change at the planetary scale. 7 billion people multiplied by the industrial metabolism today constitutes a force of change at the planetary scale. To my students, I often say that we now simply have to relate to a 369 world. In the mainstream climate science, we're heading towards 3 degrees warming, 2 degrees more than the last 10,000 years. We are basically moving out of the stability domain that has built the wealth and development that Hans so eloquently showed. We are in the 6th mass extinction of species on planet Earth, and we are committed to at least 9 billion people. This is the reality, and this is on a biosphere shaped by humanity, where health issues, sustainability issues, economic growth are interconnected in a new planetary way. Now, the evidence of this is overwhelming. This is a special issue in the journal Science, almost as good as Lancet, but on the, let's say, broader science side, showing that this is not some theory, this is not some model running, this is observations. This is the hockey stick patterns where we show that up until the mid-1950s, we basically have very little impact on planet Earth as a whole. Then 10 years after the Second World War, we put in high gear and we move into what has now been baptized the moment of the great acceleration of the human enterprise. It's in the last 50 years that we start to have impact at the global scale. And you can pick any parameter that matters for us in this room, for our well-being. It has the same shape. Everything from acidification of the ocean, deforestation, loss of biodiversity, eutrophication, overuse of nitrogen and phosphorus. When it comes to deforestation, air pollution, climate change, it has the same pattern. We're moving in a very dramatic, accelerated way with surprise impacts. We've emptied 70% of the fish stocks on planet Earth. These are the fundamental resource challenges and ecosystem changes we now have in the Anthropocene. The links to climate and health are very, let's say, prominently documented today. This is a very recent analysis of the DARA International Vulnerability Monitoring Index that comes out each year, showing that, yes, we're starting to have evidence of climate change drawing down GDP at the current stage. When President Putin closes the Russian borders for export in 2008, and when Australia shuts its border for export in 2008 because of 12 years of drought in Australia and because of forest fires in Russia, this affected world prices on cereals to the point where it may have had an impact also on getting the Arab Spring to scale. We're starting to see unexpected interconnections between social unrest and environmental change. There is highly debated numbers today on how climate change is affecting health, even in big numbers. You see these are large numbers of 5 million people being affected already today. The large numbers are on areas of air pollution and indoor health. One of those absolute unacceptable mistakes and so say unaccomplished solutions, because here we have an area of fundamental win-wins where reducing air pollution solves health issues, but at the same time reduces greenhouse gas effects. And Lena Ek may come back to this because this is one of the co-benefit areas that Sweden actually is engaged very actively in. We talk today of a quadruple squeeze on planet Earth, which I think is relevant for the agenda here today. Population pressure is of course one, but just as Hans pointed out, it's not about the numbers of people, it's about affluence. It's about the fact that 1 billion people who stepped onto the Industrial Revolution, the minority on Earth that is largely represented by us in this room, has caused the bulk of the environmental challenges and problems so far. We now have the positive development shown in the Gap Finder data that we're moving towards a world with 4, 5, 6 billion people with an average purchasing power equivalent to an average European. This is positive, this is necessary, but this growth requires a new way of sharing the remaining resources on Earth. Climate change is clearly the big anthropogenic pressure on the planetary scale, but you would have wished that this energy disturbance, because that's what we're doing. In fact, when we inject greenhouse gas into the atmosphere, we cause an energy instability which you would have wished planet Earth to be strong to absorb and deal with, to buffer. Now, unfortunately, we have evidence that we have an ecosystem crisis as well. We're undermining the basic functions in our landscapes in a way that never have been seen before over the past 50 years. Now, these losses of ecosystem services includes issues like carbon sinks, like regulating freshwater flows, like the ability to keep air quality at a high level. These are issues connected directly to health and directly connected to the feedbacks that may occur in the climate system. Now look at this very messy graph, which has all the relevance for health and the discussions today. This is the latest data by the NASA Institute on weather observations again. And you see here the 1955 map up in the left-hand corner and today map 2011. In red, you see freak events, basically extreme weather events which are more than 3 standard deviations away from the average. This is something that should occur statistically less than 1 times every 1,000 years. In 1955, not surprisingly, essentially no area on Earth has this kind of event, 1%. But in 2011, 14% of the Earth's surface experiences 3 sigma events of extreme weather: droughts, floods, heat waves. So this is the new reality where the extreme, I mean not the extreme, the ultra extreme has become normality. Now, in climate science, we today ask ourselves the question, where are we heading? Now, this is, you may recognize the IPCC scenarios of the A1 scenarios and the B1 scenarios. The B1 scenarios are the one in blue there, taking us to a safe 2-degree future. The A1 is the business as usual one, which was highly criticized because it was unrealistic. It was simply, why scare the world with a scenario where we simply don't do anything, we're just increasingly, exponentially increasing our emission of greenhouse gases. The black dots is where we are. We're following the A1 path. We're moving towards a 4+ degree world in the future, even in the mainstream IPCC assessments. This has been summarized increasingly in an integrated way by science, as Nisha pointed out here from the Planet Pressure Conference, the Future Earth Initiative, etc. The key message to humanity is we are reaching a saturation point where we can see feedbacks and surprise. These are now connected increasingly through health. This is just one chart showing a science paper where we made the point that human development must now connect ecosystem change with health and development, and particularly the links to the biosphere related to infectious diseases, zoonosis, and surprise in emerging disease patterns coming from the biosphere, so to say, hitting back into societies in surprising ways. Business is starting to understand this. This is normally how we portray surprise. This is the Lehman Brothers being sucked into the financial crisis vortex in 2008. But even the world of business welcomed humanity to the Anthropocene in 2011. Now, The Economist, a British weekly that I highly admire, had this wonderful citation in this issue, which I think reflects quite well the sentiments in science today. They said that, you know, when reality is changing faster than theory stipulates it should, a certain degree of nervousness is a reasonable response. And this, I think, is a good reflection of where we are today in science. And this is a moment, then, to take these surprise issues seriously. Now, I'll go through a couple of them linked to ecosystems. Now, we have now, at the Resilience Center, a database showing that the way we always thought nature behaved is obsolete. We've always seen nature as this big Walmart supermarket. You just go in and you take resources from the shelves. They change linearly, incrementally, in a predictable way. If a resource goes down, you simply shove in a policy and the system goes back in. This is not how nature works. We show universally that long periods of very slow change, because systems have resilience to buffer even unsustainable exploitation, can suddenly, through a trigger, tipple over a tipping point, and we have very unwanted and lock-ins in a substantive change of the system. And we have evidence from coral reef systems, lakes, the risk on savannas, etc., in observed data. This is perhaps the one, I think, potentially most dramatic one. This is Carlos Nobres and colleagues showing that even the Amazon rainforest may be much more sensitive to a flip where it could abruptly shift into a savanna state. Is that of relevance to health? Absolutely, because if the big biome rainforest tips over dramatically to a savanna, you shift the rainfall patterns across even to Africa, you shift temperature patterns all the way even to China, and you have massive impacts on climate change, and you would also have potentially risks on health disease contractions. We sit here in Sweden in a very cold winter. This is NASA data on temperature change. You see the blue dot there with the very cold, shivery winter here. We now show increasing evidence that this may be because of the warming in the Arctic, pushing down the normally high-pressure systems of the jet stream in the Arctic. So it could be a freak paradox of cold winters here being an effect of climate change affecting health. So one part conclusion here is we simply need to move away from this notion of just having one issue at a time. We need to hold many balls in the air at the same time. The kind of Björn Lomborg notion is dead, that you deal with one issue first and then you deal with another. We simply must recognize that climate change and health operate simultaneously at this time step. Now, the evidence for this was in this Global Health Action paper that was published yesterday. This is one graph from that paper. I won't go through it, just showing that climate change today clearly has exposures across a very wide battery of key areas affecting health, which then affect health issues, for example, in terms of malaria and other vector-borne diseases, which means that we can today not exclude any longer the connection between health and climate change. This is occurring today. This is a manuscript that's been submitted just as we speak to PLOS ONE, one of the high-ranking journals in the world. It's led by Jim Hansen, and colleagues, showing that for many areas that are absolutely critical for human development, from agriculture to crop diseases to health areas, we have evidence, I mean real evidence of current implications linked to climate change. And these range from everything from tropical diseases moving northwards to how high temperatures affect health among particularly elderly populations, also the risks of changes in food yields, which then would impact very dramatically on development. Now, one area of particular interest, of course, to health is how does global environmental change influence infectious diseases from the biosphere to humans, zoonosis, infectious diseases that are emerging areas which we now increasingly have to learn to deal with in a globalized world. Now, we have evidence to show that emerging infectious diseases are to 60% zoonotic, coming from wildlife in particular, transmitting over to humans. I just learned yesterday that there's a new strain of bird flu infection being identified in China as being one of these emerging areas of infectious diseases in a globalized world where our social globalization is interacting with global environmental change. That these changes in emerging infectious diseases, everything from the kind of expansion of the traditional bovine tuberculosis all the way to the new type of SARS and bird flu infections, are linked tightly to how we manage land, farming, and how we deal with climate change. Now, this is just one example, which is the poultry sector and its bird flu spread, which became quickly a globalized issue, and that happens very quickly in a globalized era of interdependence. So again, we can no longer disconnect a globalized economy between a globalized social dimension, between a globalized environmental change reality. Data from Ulf Magnusson and colleagues at Stockholm at the University of Agricultural Sciences show that the costs of these increasing surprise on the health, climate, trade area are growing very rapidly, that the SARS pandemic shows very different cost levels compared to the traditional BC type outbreaks that we had in the early 90s, and that we can foresee a future where the hitbacks on economies will be much higher from health. So there is an initiative, as you may be well aware, of several UN agencies looking into what's been baptized the One World, One Health challenge of linking environment in terms of how we manage particularly agriculture and wildlife, zoonosis linked then back to human health, and human health to development. And that this is one complex that we need to look into much, much more actively in a world of global climate change. Now, I would like to emphasize, though, just like Hans did, the most fundamental one, which is, of course, water-related shifts due to global environmental change. If greenhouse gases is linked to climate change, the first victim from climate change is water. Now look at this graph. This is, I think, one of the most dramatic information pieces when it comes to the challenges we're facing. This is colleagues from Finland showing over the last 100 years the number of people suffering from various degrees of water scarcity. Now the drama is we have roughly 3.5 billion people, half of the world's population, still suffering from water scarcity today. Now the dotted lines show the exponential success story of trying to solve this problem. This is the number of dams. We've now 5,000 cubic kilometers of fresh water locked in dams. 25% of the world's rivers don't even reach the ocean anymore, to try and deliver water for a world population. The absolute fundamental bottom line for health, to avoid diseases, to avoid diarrhea, to avoid early childbirth, death, etc. Now we're chasing our own tail because we have this exponential success, an engineering success, while still not being able to deliver water in a world where we know that climate change is going to make the hydrological cycle much, much more volatile, with the risk of very dramatic water scarcity implications, particularly in tropical regions. This is the sanitation challenge shown in recent data by WaterAid in a very important report showing that still in Africa we have very important accomplishments in the MDG agenda, but still major challenges in terms of still 30–40% people not having the basic sanitation needs. Again, directly coupled to health, but also very strongly coupled to how we manage the environment. So just in the final few minutes then, what does all this mean in terms of, could we think of an integrated framework to connect the health agenda, the environmental sustainability agenda, and the development agenda? And we believe as a science community that this is absolutely possible today. but it will require a shifting thinking. It will require moving away from the notion that economic growth is the only ultimate goal, and then we deal with all the other issues as silos: health, economics, environment, trade, to a unified framework of human development within which we have called a safe operating space for humanity. Now, to define a safe operating space for human development on Earth, we need to know what is a stable state for the planet. And this is interestingly quite easy to do today from glacial data of ice cores. The ice core data up in the right-hand corner is very interesting. It is the last 100,000 years of our existence on Earth. This is Greenland data. It's an interesting period because we've been fully modern humans for roughly 160,000 years. So this is a period when we had the same ability to build civilizations as we know it. On the y-axis is temperature, so it's a good proxy of how it was to live on Earth. And it was, as you see, a tremendously jumpy journey up until the point of entering Eden's garden, the Holocene, the last 10,000 years of interglacial with plus minus 1 degree Celsius of stability. This is our reference point for a stable planet. If you use that as a reference point, because it's the only state of the planet we know that can support 7, soon to be 9 billion people, we can then define what we've called a safe operating space within planetary boundaries. What are the Earth system processes that we need to be stewards of to keep planet habitable within a Holocene-like state now that we are in the Anthropocene? Now, the interesting is that science can today be pushed to quantify this space. It's not only climate, it's climate linked to the biosphere, ecosystems, water, land, nitrogen, phosphorus, air pollution, all the issues that matter for health. And then you can put development inside that agenda. And just 2 weeks back, we published a paper in Nature trying to suggest how the new Sustainable Development Goals could be structured in this way, where we simply say that today we need to have an economy that serves society, and that society operates within the life support systems on Earth, and that we can quantify, therefore, what we've called Sustainable Development Goals that has, for example, the whole issue of health, but that the health dimension needs to then articulate goals that are both economic and social, like education and family planning, but also goals related to climate change that need to be integrated in keeping the balls in the air to be able to accomplish the goals. To put it another way, global sustainability is today a prerequisite to achieve health goals, meaning that we simply cannot do one thing at a time. We've shown that this can be operated in a global governance sense, that we need to have more collaboration between countries in the world, this fair sharing of remaining resources. We've shown in 2 recent books that this can also be done both fast-track, but also, as has been pointed out earlier, we need to have fundamental changes in values. We simply need to recognize that 9 billion people on a small planet is moving from believing that we are a small world on a big planet to the reality of today, which is a big world on a small planet. We've done that in a way that also addresses some of the key policy measures that need to be occurring at the short term, in a book that I wrote with Anders Wijkman, former EU parliamentarian, called Bankrupting Nature. So these are examples of how science can now step out of its comfort zone to start articulating the need, for example, for a global carbon tax, the need to have a global agricultural revolution that recognizes the need for rapid delivery of growth and development also to achieve health goals. And my final slide is this one then, the kind of core message back from when I began. I think this today could be a very important moment to take a step to once and for all break the dichotomy between the silos of health, sustainability and development, and recognize that in the Anthropocene we need to simply see that we're getting feedbacks from planet Earth in real time, and therefore we also need to navigate these challenges in real time. And my final conclusion is there's no scientific evidence that we cannot accomplish a transition to a safe operating space, i.e. the future is probably brighter than the past if we only act very decisively and use health as the argument. Health is the argument that I think people truly understand. Thank you very much.